we have a series and we're adding up the series 2 plus 4 plus 8 plus 16, blah, 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 blah. That seems like a lot of work to write all that out. Okay? So we can represent this series in sigma notation. Okay, so now you'll see it in books. They'll use the letter K, they'll use the letter I. I've seen J used. It doesn't matter. N, okay? The variable is irrelevant, but this is the lower limit of summation. This is the first number you put into the formula, okay? You start with the lower and you go up to the higher, okay? So if you put K is equal to 1 in here, you get 2 to the 1. And then you put the next number. What comes after 1? 2. So then you put the 2 in for K, and you get 2. And then you put 3 in, and you go all the way up to 2 to the 8. And the reason it's got this addition sign is because it's in the sigma notation, which means you're adding everything together. Okay? That's all sigma notation means. All right? Add all the numbers for the formula 2 to the power of K from K is equal to 1 to 8. That's it. That's all you're doing. Is everybody okay with that? Where's the middle group? Why are we missing any? Oh, wasn't that like Saturday night?
Yes, and I'm still tired.
Oh, they forced you?
Yeah, I was trying to leave at 11.
Okay.
Yeah, I did.
Yes.
All right. Like I said, K can, it doesn't have to be K, it can be I, J, N, whatever. Okay. So write the series represented by the sum from K is equal to 1 to 8 of 2 to the power of K in expanded form and determine the sum. How many terms are there in the series? Okay. So we just started that actually. So let's just quickly do it again. So we put 1 in, I get 2 to the 1, and then it's 2 to the 2, and then it's 2 to the 3, and then it's 2 to the 4, and then it's 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8. What's 2 to the power of 2? 4. What's 2 to the power of 3?
16.
All the way up. 2 to the power of 8 is 256. Okay. Now, you could literally, on your calculator, go 2 plus 4 plus 8 plus blah, 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 blah. But what would be a better way to do it? Using the things that we've used, formulas that we've used. So the better way would be to use a summation formula. Which summation formula would you want to use? It actually doesn't matter. But which one would you choose?
The first one.
Oh, controversy. Let's do them both. So we can use the first one, a r to the n minus 1 over r minus 1. Or we can do it using the second one, which is r tn minus a over r minus 1. All right. What's my a value? Well, for the first one here, what's my a value? 2. 2 times. What's my r value? What's the r value? R? R is 2 because they're going up by 2s, right? Or multiplying by 2, by a factor of 2. How many terms? This is the key here. How many terms are there? What's n? Count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. So it's 2 to the 8 minus 1 over r minus 1, 2 minus 1. Okay. If you use the second formula, r we said was 2. Tn is the last term, right? Which we know, and you can calculate just by plugging in the top number there. 256 minus our a value, which is 2, over 2 minus 1. Either way, both of them give you the same answer of 510. Now, just be careful. You're going to see later on. Don't assume that this formula here is not always written in AR n minus 1 form. You can't just look at that formula and pull out your A and your R value. Okay? You have to write it out sometimes to see the A and the R. I'll show you that in a sec here. All right. Are there any questions about what sigma means so far? Just means add up all the terms, starting with the bottom number goes in and all the way up to the top number. Going once, going twice. Zoom. All right. Write the series in expanded form and determine the sum. All right. So now they're using K, and they're not starting at 1, they're starting at 5. Isn't it? What? It's Monday. Welcome. All right. So what number do I put in first? 5. 5 goes in for K. So when K is equal to 5, I get 5 times 2 to the 5 plus 1. That's going to give me, what's 2 to the 6? 2 to the 5 is 32, 64. 64 times 5 is 320. Is everybody just going to nod their head in agreement with me? Oh, you did it? Perfect. Okay. That's K is equal to 5. Now I'm just going to write out the rest of the series. Then we plug in the next term. What do I plug in next? What number for K? 6. So it's 5 times 2 to the 6 plus 1, so it becomes 7. And then you do the next one. 5 times 2 to the 8, because you plug 7 in. 5 times 2 to the 9 when you plug the 8 in. So it's going to be 320 plus 640 plus 1280 plus 2560. Okay. So now you could just simply add all these up because there's only 5 terms there, right? Or 4 terms, sorry. 4 terms. There's 4 terms. You could just punch those into your calculator. But if I asked you to sum to a higher number, like say the first 100 terms, that you don't want to do that. So the reason you write it all out is because if you're going to use a formula here, what is my A value for this series? What's the first term of the series? 320. That is my A value. The R value is what? How are you getting the second term? R value. Just look at the numbers. Not divide. Oh, yeah. Okay, sorry. Divide the term in front by the term behind. What do you get? 2. You're doubling it. Okay? So this is why you can't just look at the formula that's written here. Like some of you would have guessed, okay, that's my R, right? But the A is not 5. This is not written in AR n minus 1 formation, okay? Because it starts at 5 as well. K is equal to 5. So you have to write out the first couple terms to see the numbers, all right, if you're going to sum it using those formulas. So just be careful about that. I actually don't care what the sum is, but if you added them all up, you get 4,800. All right. Now, if I ask for the number of terms in a series, all right, obviously if it's between 5 and 8, you could literally just write them out and count them. But if I give you a bigger range, the way you find it is it's the upper limit minus the lower limit. So in this case, it would be 8 minus 5, and then add 1 to that. Okay, 8 minus 5 is 3. 3 plus 1 is 4. So if I gave you something that looked like this, sum from n is equal to 5 to 60 of who cares, whatever, and I said, how many terms? How many terms are there? You just go 60 minus 5 plus 1. So that's 55 plus 1. There's 56 terms. Okay? Top minus bottom plus 1. That'll give you the number of terms. We good so far? All right. Okay, here's our series. Now we're going to go backwards. Instead of giving us sigma, we're going to work backwards. We're going to get the series and write it in sigma notation. So here it is written out. What is my A value? What is my R value? And what is my N value? What's A? 3, first term. What's R? A half, right? If you divide the term in front by the term behind it, 3, which is like 3 over 1. 3 over 2 times 1 over 3, those go away. You get 1 half. Okay? So R is a half. N, how many terms? That's what I'm asking. How many terms are there? There's 6. You can count them. 1, 2, 3, 4, 5, 6. Okay. So when they ask you to write it in sigma notation, you're going to write it as ARN minus 1. So it's the sum from n is equal to 1. That's the first term that goes in, all the way up to the sixth term, ARN minus 1. And then just plug in A and R. Of A, which is 3, R, which is a half, to the power of n minus 1. That is that series represented in sigma notation. And you can't do anything with the 3 and the 1 half because they're different. They have different exponents, different bases, and they're different bases. If I ask you to write it, you always write it with n is equal to 1, because if you put 1 into here, 1 minus 1 is 0, right? Anything to the power of 0 is 1. So that's 1 times 3, which gives you your first term. Okay? So if I ask you to write it in sigma notation, you're always going to do ARN minus 1. But I can give it to you in a different form. All right? Sort of like this one. Determine the value of the sum from k is equal to 0 to 20 of 5 times 4 over 3 to the power of k. All right. So first thing, figure out, yes. You should write n equals 1 or I is equal to 1 or whatever it is, because in the formula you have it. Right? Okay. Determine the value from k is equal to 0 to 20 of this series. So first thing, plug in your first couple of numbers and you'll see what A and R are. If that makes any sense. So at k is equal to 0, what do I get? What's anything to the 0 power? 1. So what am I left with? 5, right? Because if you put k is equal to 0, you get 5 times 4 over 3 to the 0, which is just 5. So that's your A value, or k is equal to 0. It'll be A, or T1. T2, that's when k is equal to 1. So you get 5 times 4 over 3, which is 20 over 3. Okay. We're going to sum this series. So we need to figure out the number of terms. How many terms are there? What do you do to find terms? Upper minus lower plus 1. So there's 21 terms because it's 20 minus 0 plus 1. So there's 21 terms. So that's n. So we've got n, we've got a. Our T2 is this. So what is our R value? Sorry? It's 4 over 3, right? First term was this. Second term was 5 times 4 over 3. Right? So R is going to be 4 over 3. Okay. We've got A, we've got R, we've got N. Which formula are we going to use to sum them? Of the two summation formulas. Top one or like the middle one or the last one? Middle one, right? Because we don't know the last term. We could figure it out by plugging in n is equal to 20 if you wanted to, but I don't really want to do that. So we're going to go Sn is equal to A R to the n minus 1 over r minus 1. Okay. Plug it in. A is 5, R 4 over 3 to the power of n, which is 21 minus 1. You can do decimal on your calculator. Oh, it even asked for the nearest tenth. So let's see if we all get the same answer. I will ask you to do this on a test, so please practice it. $1691.74, 7, because it asked for the tenth, so I should have done that. Do it in steps. Don't, if your calculator is not one that can keep all the brackets in order, just do it in steps.
There you go.
Good.
So was I typed in 23 instead of 21?
That would make a very big difference.
I'm using these labels.
All right. Ready? Questions? Concerns? Take your silence as sort of. We're good? All right. Okay. A sequence is defined by the recursive formula. Well, T1 is equal to 3, Tn is equal to 5 times T to the n minus 1 when n is greater than 1. What the heck does all this mean? All right. So list the first 4 terms of the sequence. So basically, what's T1? They tell you. T1, or A, is 3. They've given you that piece of information. Okay. T2. So you put n is equal to 2 into this formula, into this. Okay? Because only the very first term is defined for you. Everything else is defined off of that. So if I put T2 into there, I get 5 times T2 minus 1, which is T1. Does that make sense? All I did was put n is equal to 2 into this formula. I put a 2 there, I put a 2 there. 2 minus 1 is 1, so 5 times T1. Well, T1 was 3. So T2 is going to be 5 times 3, which is 15. There's T2. T3, so you put 3 in for n, you get 5 times T2. T2 is 15. That gives me 65. That's my third term. And they want us to do the first 4, so we'll just do the first 4. T4, I put 4 in, it's going to be 5 T3, which is 5 times 65, which is 325. Does that make sense to everybody? You're just plugging in n is equal to 1, n is equal to 2, n is equal to 3.
Like the term ratio to like 75.
Yeah, because 5 times 15 is 75, not 65. Thank you. Oh, and that's going to change. Is 5 times 75 325? 77 75 is 150. That's 300. Another one is 375? 375? Yeah. Thank you. There we go. Okay, so 375. Thank you. Okay. All right. Find the sum of the first 12 terms of the series. I don't want to continue that process, so we're going to use our formulas. A, R, n is equal to 12 because I want to sum the first 12. All right. What's my A value?
3.
3, first term. What's my R value?
3. Or sorry, 5.
5. Correct? Is that right? R is equal to 5. N is equal to 12. Which formula are we going to use? Middle one? First of the sum, middle of the ones up there. Sn A Rn minus 1 over R minus 1. Okay. Plug everything in. 3R to the 12 minus 1 over R minus 1. All right. Again, calculator practice time. This is going to be a big number. $183 million, blah, 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 after that.
Yes.
So we got
Yeah.
that number, 183,105,468. All right. Okay, last thing. Represent the series in sigma notation. So again, if we're going to write something in sigma notation, we start at 1, n is equal to 1. We're going up to n is equal to 12. And it's always in the form ARN minus 1. So just plug it all in. A value was 3. R value was 5. And there it is. That's the series in sigma notation. From 1 to 12, that will equal 183,105,468. And there you go. That's it. Does that make sense? All right. Number of terms is top minus bottom plus 1. If you want to find out your A and your R value, you just plug in A is equal, or n is equal to 1, n is equal to 2, n is equal to 3. You'll see the pattern develop because we're only dealing with geometric series here. That's it. Number 1, 2, A and C, 3, B and C, 4, 5, and then 7 to 9, please. and we're almost done the unit.